similar to the single sum for unknown interest and number of periods I introduced, we can also solve the similar problem for annuities. In this example, assume you borrow $700 from a friend. Intend to repay amount 4 equal annual installments beginning 1 year from today. Based on this description, we know $700 was borrowed at 0. Then you repay 4 equal annual payments in the next 4 years. The first installment starts at the end of year 1. Second, third, fourth. So these repayments actually, they are an annuity. Interest 8%. Since the payments was made every year, so we assume the interest is compounded annually. And 700 actually is the present value of this ordinary annuity. Okay, so the timing of these payments regarding original 700, we know this annuity is an ordinary annuity. So we can convert this problem to the present value of this ordinary annuity equals payments multiplied present value factor of ordinary annuity, which is determined by N and I. Present value is 700. Payments was unknown or to be solved. We know N is 4 while I is 8%. So we can figure out this problem. So the present value is 700. The factor we look up 4 years, 8% for each year. The factor, then we can calculate the amount for installments will be $211.34. So this is an example when the payment is unknown. Assume the present value 700. Based on this chart, this indicates this is an ordinary annuity. We are given 7%, but we don't know how many periods. So what we should do, we still apply this formula. Present value equals to the payment multiplied present value factor. So based on this equation, we can figure out, okay, the factor for the present value of ordinary annuity was 7. We can look up the table. You can find it in the textbook. You can locate this number, which was close to 7 in row 10, or it indicates N equals to 10. That means there are 10 periods. The interval of each payment is every year. So N equals 10 means 10 years. For this example, the interest was not known to us. We need to solve it. We are given the present value and the setting of this annuity, 100 each year, should be an ordinary annuity. So the present value 331 equals the payment 100 multiplied present value factor of ordinary annuity. We know the number period is 4. We don't know I. Then we convert this equation to 331 divided by 100, so we can get the present value factor. It equals 3.31. Then we can look up the table, row number 4, to find the interest I. Okay, so this is a procedure I just showed you. Okay, we look up table for ordinary annuity. We find it locates in column 8%, so interest is 8%.